Welcome back to this series on special topics in elementary mathematics. In this video, we'll address one of the most perplexing aspects of multiplication. What does it mean to multiply by a negative number? We'll take a look at multiplying by negative numbers through the models of multiplication you should now be familiar with. But first, I want to ask you to come up with your own answer to the question, what does it mean to multiply by a negative number? Post your brief thoughts in the online discussion forum. How should we think about multiplication by a negative number? Well, the same way as we've thought about other aspects of multiplication, with models. In the past, we've looked at arrays, rows, areas, and scaling, along with other suggested models. Today, we'll focus on the scaling model of multiplication to see how negative numbers can be incorporated. First, let's review the scaling model of multiplication. Remember, we can think of scaling as fixing one end of a segment and stretching or squeezing it by moving the other end. This kind of scaling keeps the segment pointing in the same direction. If we think of the segment as being on a number line, then the fixed endpoint is at 0. And when the scaling factor is applied, the segment is stretched or squeezed by moving the other endpoint. What if we want the scaling factor to be negative? How does scaling work then? On a number line, the interpretation of negative numbers is clear. A negative sign means reverse the direction, move to the left instead of the right. So how might we scale by -1? Well, we just reverse the direction of the segment. Once we have this idea in place, multiplying by other negative numbers becomes more accessible. To scale by -2, you would double the length and reverse the direction. For example, the number 4 is represented by a length 4 units long and pointing to the right. Multiplying -2 times 4 produces a length 8 units long pointing to the left, which is -8. We can also interpret multiplying a negative number by a positive amount. Now, a negative number is not just a length, but a length pointing to the left of 0 on a number line. If we scale this by a positive amount, it remains pointing to the left, but with a new length. For example, the product 3 times -3 means to scale a length 3 units long and pointing to the left by a factor of 3. The result is -9. Now let's check that introducing negative numbers into our model hasn't upset its important properties. For example, can we see that this model with negative numbers still reflects the commutative property of multiplication? Remember, the commutative property states that A times B equals B times A. We should still find that this is true when one of the numbers is positive and the other is negative. More concretely, look at the products -2 times 3 and 3 times -2, and interpret them in two different ways. First, treat 3 as the length and -2 as the scaling factor. Then treat -2 as the length and 3 as the scaling factor. In the online discussion forum, describe these two processes and their results. Now we're ready for the perennial question. What does it mean to take the product of two negative numbers? Somehow it's easier to think about when each of the factors represents something different. For example, in the product -2 times -5, we'll let -5 represent a length pointing to the left, and -2 be the scaling factor. When we multiply, the 2 means that we double the length of -5, and the minus sign means that we reverse the direction of -5. The result is a length of 10, pointing in the positive direction. Now it's worth observing again how this interpretation shows that multiplication is different from addition. When adding positive and negative numbers on a number line, positive just means move to the right and negative means move to the left. Multiplication by -1, however, means reverse the direction. If the length pointed to the right to begin with, make it point to the left. And if it pointed to the left at first, make it point to the right. With this perspective, hopefully the old rule that the product of two negative numbers is positive gains some added clarity. Multiplication by one negative number reverses the direction once, and multiplication by two negative numbers reverses the direction twice, thus restoring the original direction. We focused in this video on how scaling can be used to model multiplication by negative numbers, and we've used that model to see why a product of two negative numbers should be positive. To end this session, try thinking of other ways that multiplication by negative numbers can be modeled, and see if you can use them to gain insight into how this kind of multiplication behaves.